Okay, this is our last set of notes for Chapter 9 for Algebra. We're going to kind of lump a little bit of 9-7 in with 9-8, and I'll explain that when we get there. So, you may remember the special products that we had done before. When you multiplied these together, they would be a squared plus 2ab plus b squared. This one would have been a squared minus 2ab plus b squared. And this one would be a squared minus b squared. So if you take a look at these, one way to help you factor, might make it quicker, is if you look at these, and if you notice that both of these are perfect squares. If they are both perfect squares, then this is going to factor down into your two binomials. Put an a in the front of each one. A times a would be a squared. Put a 7 in the last position in each one. 7 times 7 would be 49. And then how would 49 be negative? One of these is a plus and one of them is a minus. And that's it. That is showing you the difference of perfect squares pattern of factoring this, which would have been just a binomial. Same thing on number 2. You notice that this is a perfect square. You notice that this is a perfect square. So you put an x in the front of each. Put a y in the back of each. One is a plus, one is a minus or negative. When you factor those all together, if you FOIL those all together, you will find that you get back to your original answer. So I feel like that one is super helpful. The other one I think is helpful as well, so just pay attention. When you get to a trinomial, look at the first term. It is a perfect square. Look at the last term. If it also is a perfect square, then you should check to see if maybe you are dealing with one of these top two special products up here. So, how you would know that is the square root of x squared is x. The square root of 36 is 6. So together that's 6x. If the middle term is that doubled, then you are dealing with one of these special products. And in this case it is. So x in the front of each, 6 in the back of each. And then what would you need here? You need 6 times 6 to be positive 36, and then it adds together to be positive 12. So these are both going to be positive. So then your final answer, you could leave it like that, or you could write this as x plus 6 squared, which would mean x plus 6 times x plus 6. So again, on number 4, perfect square out front, perfect square in back, or perfect square in the first term, perfect square in the last term. Square root of y squared is y, square root of 9 is 3. So that would be 3y. Is this middle term that doubled? Yes, it is. So you've got one of the special product cases. Put a y in the beginning of each, a 3 in the back. And then in order for these to add together to give you negative 6y, they're both going to be a negative. And again, you could write your answer as the quantity of y minus 3 squared. So for tomorrow, you need to work questions 5 and 6 in this box. But don't stop this video yet. We want to talk a little bit about 9.8. So if you would flip your paper over, and I want you to pause the video and write down what I have here. You don't necessarily have to make this box, but I want you to write 9.8, factor polynomials completely, write space to put 3 steps up here, and then write down these 2 problems. And then you can unpause and we'll talk about this. So, end of the chapter. This is what you have to do every single time you go to factor any polynomial. First thing you have to do is factor out the GCF, or a lot of times we will call it the greatest common monomial factor. This would be like factoring out -1 in some of the problems that we have been doing. And we factor out -1 when the first term is negative. So, but you might be factoring out a 3. You might be factoring out a 3x, a 7ab, something like that. So every single time you have to think of this first. The second thing you look for would be what we just talked about earlier in these video notes, is look for special products. So that would be the difference of two squares that we just did. That would be one case where you had a binomial and we factored it down into two binomials. So look out for those. And then you factor any trinomial into two binomials. So into the product of two binomials. Okay, so let's go through some examples down here. So if we look at these, and you should have already written these down, factor out the GCF. I see 2y cubed minus 12y squared plus 18y. First, look at the numbers. What number could you factor out of all three of these? You could factor out a 2. And then this says y cubed, y squared, and y. So they all have a y in common. You're going to pull that out front too. So then kind of do a reverse distribution. 2y times what would get us this first term? Put a 1 as a placeholder if you want, and then you need y squared. If you don't want to put that y, that's okay. Check yourself. 2 times 1 is 2. Y times y squared is y to the third. Minus or negative. 2 times 6 would give us 12. 2 times that, 6. And then y times y would give us y squared. Plus or positive. 2 times 9 would give us 18. Or 2y times 9 would give us 18y. So we are finished. You have factored out the greatest common monomial. And I said we're finished, but I meant we're just finished with that step. So now, special products. This first thing is a perfect square. This second thing is a perfect square. Square root of that is y. Square root of that is 3. Is this middle term 3y doubled? It is. So this is actually an example that has a special product involved. So when we go to factor this trinomial to two binomials, y goes in the front of each, 3 will go into the back of each, and then since we want these to multiply together to get positive, but add together to get negative, those are both going to be minus or negative. And then your final answer could stay like that. Probably actually better to write it like this, but either is okay. So that is the end. We have factored completely. If you FOILed this back together and then distributed the 2y through, you would get back to this. If you don't, you made a mistake. Okay, same with this one. We have 3 that we can factor out and also an x. So 3x times x will give us 3x squared. Minus or negative, 3 times 4 would give you 12. 3x times 4 is 12x. So we've gotten that one. Okay, think about special products. So if this were a perfect square, then it would be possible we could do something with it. But it's not. There are no common factors of this, so that would be the end of that problem. Okay, what I'd like for you to do for tomorrow, in addition to the 2 problems you did in the box on the front of this sheet, is to write down these 2 problems and have them finished as well. Thank you for watching.